Okay. Hi. I think it's recording. My name is Mr. Cleland. We're going to do reflections today, but one across the regular axes. That one's super easy. And then I'm also going to show you one where we go not across the regular axes, just for fun as an extendo. So let's do this. Thank you for your patience, everybody. I appreciate it. Okay. Whoa, is this upside down today? No, that's right. It's just backwards on my screen. Okay, so reflections. They're fun. Let's take our battleship here. Actually, I've got a perfect example. Battleship right here. So we were playing some battleship. We want to reflect across the X or Y axis. This is really simple. There is a mathematical way to do this. You can check out the cheat sheet for that. If you know your points, you can just do that. But in a practical sense, reflecting across the x-axis, you just know that it is the same distance away from the x-axis. So if it's 1 away from the x-axis here, then if I reflect across that, it will remain 1 away from that same axis, and it won't have any change in terms of its x coordinate, but the y coordinate will be inverted, right? So if it's this first one, let's take this point right here. So if that was a 3, 2, then down here, that exact same reflected coordinate would end up, actually, 3, 2 would be down here, reflected across the x-axis, would be still a 3. The x doesn't change, but the y gets inverted to -2 because it's the same distance away, but in this case, down across that x-axis. And it's as if I took this and literally caused a reflection to show it across that x-axis, like a mirror. Pretty straightforward. Y-axis is the same deal, but instead of the y coordinate this time is now not going to change. It's going to be the same distance up. So that this point right here, 3, 2, if I were reflecting across the y-axis, it would end up being over here somewhere, as if I put a mirror on this line and shone it across that y-axis. So it's going to be the same distance away from that. So that's 3 over. So would it be actually 3 to the right? It becomes 3 to the left. And so that would be my point right there. And so my x-axis, when I'm going across the y-axis, the x changes. If I go across the x-axis, the y changes. But the other coordinates stay the same. So this is across the y, this is across the x. You could also do the same thing when you're reflecting across the line that is made when you do y equals x. That's a terrible diagonal. And again, in a practical sense, you just keep it the same distance away from there. So if I had a point, let's say up here, that's 4, 5, 6, 7. And 5. If that was across here, I would keep it the same distance away from that diagonal. Let's assume I drew it properly. So it's 1 away from that diagonal. So it would stay on that diagonal path by 1, meaning it would end up right about there. And then I would figure out what that is. So that would be, I believe it inverts. So it's 5. And it would be up, it should be up by 7. 3, 4, 5, 6, 7. So you can see how the xy invert when you're going across the line that is a y equals x. And all of this is done in those cheat sheet quick numbers, or you can do it in a more practical sense on the projection screen, cool, on your grid. Now, let's remind ourselves when we get a weird one. So I'm going to go down to here, and I'm going to bring in my little portable screen, my portable axis, which I made from an old face shield. Yeah, talk about making lemons into lemonade, eh? So let's say I'm going to take this point right here, 2, 3, and let's give it a name. Let's call it what letter? A. A is so. Let's go with S. I heard an S after an A. Let's go with, that's point S. And I'm going to reflect this, but let's say I'm reflecting across a weird axis. like, let's keep it still somewhat simple. Let's pretend our axis is over here, or our line of reflection is over here at -2, right? So that's going to be my reflecting line. Now, from a very practical sense, if I have a reflective surface, I can actually go ahead and kind of cheat this until I can actually see that across that axis. But the other way to do this is, of course, with my handy dandy Slido screen as I knock stuff over. Just keep in mind, I'm effectively translating my grid by 2 points to the left, which from a point standpoint, this little S point, it's as if I'm moving the original point to the right. I'm moving the grid to the left, so it's as if it's the same thing as if I was moving my point to the right by 2. So I can essentially pretend like this is a different point. So if I moved it to the right by 2, this x-axis, x coordinate would be a 4, right? So let's pretend for a second that S is actually 4 and it's still the same y coordinate, which I believe was 3. So let's pretend for a moment that S is 4, 3, and that my grid is here because I've effectively translated it from where it is, -2, and then that means the point would be 2 higher. Now I can do the same trick. I can simply reflect across this moved grid, and it would end up an equal distance away. So it'd be way down here at -4 on the new grid, which would place it right there. See where that is? Now, when that's all fine and dandy, I don't need to mess with the y coordinate at all. I'm just keeping my eye right on that spot, and this is going to be where it ends up. However, I need to now figure out what that coordinate actually is if we take away our translated grid. So we moved it left by 2, so now we need to move it back by 2. And remember, it's all, inverted on your point. So this is not the actual point anymore. We're re-inverting it. I know where it is. It's going to be here. So I just need to find out what this address is. So I could, if I'm plotting it, I could just look at it and be like, okay, -1, 2, 3, 4, 5, 6. So I know it's -6. And I know the y coordinate hasn't changed. So that's going to be my S prime. That's the easiest way to do it. However, you could do it in your head as well, just keeping track of, I've moved it left, then I moved it right. So the point is effectively doing the opposite. So you can kind of just say, what have I added and taken away, and then be done with it. But I kind of prefer to visualize it because it keeps my brain from turning inside out. Does that make sense? Okay. Hopefully that makes sense to you. If you have any questions, feel free to hit me up in class or in the comment sections or by email. Okay? And thanks for joining.